Hi everyone, let's learn Retrieval Augmented Generation Systems under 5 minutes. So what is RAG? RAG is basically consists of three parts. One is retrieval of the information, and second one is how we arrange the context that is retrieved from the documents, and last one is generation that LLM generates text for us. So like I said, RAG is retrieval plus generation. Whatever documents we have in our corpus is fed and chunked into smaller pieces. Then each of these chunks is embedded into a vector database. When a user queries a certain question or a query, the relevant chunks are chosen from the vector database and then they're arranged and given as context to the LLM to give an answer to the users. That's how RAG works. That's the basic principle of RAG. You are doing information retrieval. There are five main steps. Chunking, that is dividing the document into smaller chunks. These chunks can be fixed size chunks, say after 500 characters, or say semantic chunkings, like say sentence based chunking after a sentence, then you chunk, or you do more advanced methods of chunking where you divide with paragraphs or by headers if it's a .md file. So that would be intelligent forms of chunking. Next is embedding. Each chunk is embedded into a vector that is converted to numbers and that is stored in a vector database. So these numbers are stored in a particular fashion. So whenever the RAG system runs, the retrieval would want to retrieve the relevant chunks. So the vectors are mapped and matched. So whichever vector is closer, the relevant chunk is chosen and given as the context. Ingestion is the process where this whole thing happens, where the chunks are converted into embeddings. That's the ingestion part. Now, in the creation of the vector database is the ingestion step. Queries when user asks a question, and retrieval is when you see the answer from an LLM. Let's zoom through each step. So this chunking can be fixed size chunking, say a particular token limit or a character limit of a model. And there are different chunking strategies. If it's too small, then the context is not enough for the model. If it's too big, then we might be just giving it noise. Semantic chunking is based on boundaries, embeddings, and ingestion. That is once we documents prepared and normalized, then it's embedded to vector and it's stored inside a vector database. The similarities that is used to search the database can be cosine similarity or dot product. Or in simple terms, is how closer or far away each vector or each chunk is with each other. Based on the similarity, they are mapped. So for that, we are using certain mathematical concepts like cosine similarity or the dot product, or it can just be the distance that is there between them. So so this is just quickly what I was talking to. Top K is the top K chunks that is retrieved. Say my top K is 5, so top 5 most similar chunks would contain that. So how would you rank these top K chunks? Is based on your ranking. So most relevant chunk would be ranked 1 and the least relevant would be 5. So LLM say that's at the very core of LLM is randomness and non-determinism. Every time you ask it a question, it won't give you the same answer. That's the whole point of LLM, right? So for us to determine that each time we run a rack system and ask a question, how do we always get the same output or right answer? So quickly, we have temperature. That is how random the answers can be. Top K is the most number of on the fixed number of chunks that is retrieved. The top P is how probable they are based on the probability than rather than the score. Quickly talking about evaluation metrics, we have hit rate, MRR, faithfulness, and correctness. More on this we'll learn in the next video. Thank you so much for watching this video. If you like, please subscribe to my channel and please help me grow this, please. Thank you.